Alright, so in this video we are going to be talking about primes, so let's get started. Alright, so you've probably seen a special type of integer called a prime, and it's a number like 7. Let's take a look at 7. What two numbers, when you multiply any two natural numbers, can you get 7? Is it possible? Well, 2 times 3 is 6. 2 times 2 is 4. But we can't seem to find anything that is multiplied to get 7 except 1 and itself. So 7 is equal to 1 times 7. 1 times 7 is 7. This makes 7 prime. So a prime number is when it's the only two numbers when you multiply to get that number is 1 in itself. So in this case it's 1 and 7. Another example would be 3. It's the only factors are 1 and 3. So that's how you could write 3. Now primes are super important because it's important to differentiate between composite numbers and primes. Composite numbers are like 8, which 1 times 8 is 8, but 2 times 4 is also 8. Since 2 times 4 is also 8, 8 is composite. Now, primes are useful in many types of problems, especially number theory problems and even counting problems, as we'll talk in the next couple of videos. Now, it's important to recognize primes. To recognize primes, you have to see, well, let's take an example. 17. 17 is clearly not a multiple of 2, and it's not a multiple of 3 either. But that does not mean that it's prime. We have to do a few more test cases to see if 17 is prime. We have to test 5. 5 does not go into 17 perfectly, so we still don't know. Now we have to test 7. 7 does not go into 17. So this means that 17 is prime. Because clearly we cannot find any two numbers that go into 17 other than 1 and itself, making 17 prime. Now, let's see a real-world example. If we were trying to find out if 101 is prime or not, how would we go upon doing this? Well, we first need to analyze 101. 101 is not divisible by 2 because it's not even. That means it's not divisible by any even number. 101 is not divisible by 3 either, because the sum of the digits, 1 plus 1 is 2, which is not divisible by 3. Now, this means that any multiple of 3 is not going to multiply to get 101. Now let's test. We're testing 1. We already know 1 works. 2 does not work, so we're ruling out 2. 3 does not work, ruling out 3. 4 does not work, it's a multiple of 2. 5. Let's test 5. The last digit does not end in 0 or 5, so it's not 5, and it's not any multiple of 5 either. 6 is a multiple of 2. 7. Now 7 is a number we need to test, and 7 is a prime. I think you can probably tell that 7 does not go into 101. So 7 does not work, and no multiple of 7 works either. 8 is a multiple of 2, and basically all we have to test are the primes. Products of primes are what we need to test when we're testing prime numbers. And there's a special way to do this, which I will go over in the next video. But see if you can figure it out. How can we test if any given number is prime or not? And it involves square roots.